Hello Matrix and welcome again. Today what I'm going to be doing is looking at the midpoint and the prop theorem and when you can use those as acceptable proofs or reasons in your final matric geometry paper. And I'm also going to look at when you can't use them and then when you need to use another reason. And this is based on what you're given. So let's say that we are given, and we're going to look at the midpoint theorem, that these two, so this would be a triangle, ABC, and the bigger triangle is DE. And so we were given that AB equals BD and AC equals CE. So if you saw this, you need to recognize this as it's a midpoint theorem. It's the midpoints of the two sides are being cut. And so let's read what the official exam guidelines say about the midpoint theorem. The line segment joining the midpoints of two sides, we see the two sides, is parallel to the third side and equal to half of the length of the third side. So when you see this, you can use midpoint theorem as a reason for saying the following. You could say that BC is parallel to DE, and your reason would be midpoint theorem. The second thing you could say is that BC is equal to a half DE, and that would also be the reason midpoint theorem. Now this is when they would accept that as a reason. You could also say DE is equal to 2 times BC. Now let's look at when you are not looking at the midpoint theorem as a reason. So if I say the line drawn from the midpoint of one side of a triangle parallel, so we've got this again, we'll call it A, B, C. Let's do a different color. We'll do it in green. So we've got A. Okay, so this was the yellow, the midpoint. Let's do green. So we've got A, B, C, C, D, E. Okay, and I've been given that this is parallel. And we're saying that it's the midpoint of one. So we're given that it's the midpoint of one, but we're not given both midpoints. We can therefore say that BC is equal to CE. And instead of using the midpoint there, we cannot use this as a reason. We have to say line through midpoint parallel to second side. So we see line through midpoint is BC parallel to the second side is the reason you could say that AC is equal to CE. So you would say, from this, you could say AC equals CE. And I'm going to do this small because we don't have much space. This reason here. Okay, so it would be line through midpoint parallel to second side. Okay, so we see the difference between the midpoint when you can use the midpoint and when you can't. And so we need to learn this one, which is a bit trickier to learn. Line through the midpoint parallel to the second side, and that is your reason. And then you can say that AC, so you could say that then this was equal to this CE. All right, so that is when you can use your midpoint theorem. Now let's look at the prop theorem. Okay, so the prop theorem I'm going to do in pink. And we did a video on the prop theorem. So if you want to know the proof for the prop theorem, I'm going to put a link in the video now and you can check out the proof, which you need to know It's examinable in your final exam. All right, so prop theorem, let's look at it. A line drawn parallel to one side of the triangle divides the other two sides proportionally. Okay, so prop theorem, proportional, you can see. So it's not got nothing to do with the midpoint, it's got to do with the proportionality. Let's just get the pen. Okay, so we've got A, B, C, and D. And E is the bigger triangle, ADE is the big triangle. And let's see what we were given. Well, we would be given a line parallel to one side divides the other two sides proportionally. So all we're given is that. Now, do you see that it's very similar to this? And this green one is in a way the same because we see that these are in proportion because AB over BD is equal to AC over CE because they both are equal. So prop theorem is not unlike the line through midpoint parallel to second side. So let's look at what we could then say. We could then say that AB over, and we can say AD or we can say over BD, but I'm just going to say AD equals AC over AE equals, and then BC over D over DE. Okay, so this here just deals with the proportionality of the two opposite, but we can also say that BC over DE is in proportion as well. All right, and that reason you could just say prop theorem. Okay, so I'm going to take this away and let's just say prop theorem here. All right, but just know that these can also, once these are parallel, these are also in proportion. So BC over DE is also proportional to AC over AE. All right, so I'm just going to then say, so if we look at the green, so AE is the full green, so that's kind of there, and AD, the big triangle, is there. And then the little triangle, we're looking at AB and AC. Okay. So now let's look at the one where we're given, if a line divides two sides of a triangle in the same proportion, then the line is parallel to the third side. So again, this is the opposite way of looking at it. So this could almost be converse prop theorem, but we don't call it that. We say line divides two sides of a triangle in proportion. So if you were given, and let's do this final one now in blue, so A, B, C, D, E. So let's say that we were given this AB as 1 and BD as 2, and we were given this as, say, 2 and this as 4. We can see that AC over CE is 1 is a half, and also AC over AC is a third because it's 2 over the full length, which is 6. And here, 1 over the full length, which would be 3, is also a third. So 2 over 6 is a third. So you could say that now what we would say is AC, well, let's actually do AB first. AB over AD. So we're doing this, but we're doing it the other way around because we don't know these are parallel. AB over AD equals AC over AE equals a third. Okay, 1/3 total length, 2/6 total length. Therefore, BC is parallel to DE, and our reason is line divides two sides of triangle in proportion, in prop. Okay, so we see the difference. One, you're given the sides, and you're told that they are, for the first one, the midpoints, and you can therefore say that they're parallel because of midpoint theorem. The second, you're given that it's parallel. Therefore, you can say that AC is equal to CE. Now, with the prop theorem, you are given that the sides are parallel. And so if you're given the sides parallel of a triangle, therefore you know that these sides are divided in proportion. And if you're not given that, but you can see that the sides are in proportion, it's a slightly more difficult one to remember, but you can say that BC, in this case, BC parallel to DE, because the line divides the sides into proportion. So learn these accepted reasons. They are important. And next time I'll be looking at equiangular triangles. So if this helped you, please find the subscribe button down below, like, share with your friends, all that good stuff. And I will see you again for the next lesson.